Happy Friday, all. So I don't know why I thought I could finish the drilling yesterday, just adding up the machine time. There's just not enough physical time in the day. I mean, there is enough physical time in the day, but I do enjoy sleeping at some point. Which reminds me, this weekend I want to work on that little code implementation to basically fail-safe check some of the operations on the lathe so I can leave it more unattended. It'd be very helpful if even in the evening I could leave it for a few hours and just let it run some small parts, like thumb studs, for instance. They don't take a long time, but I can make like 50 or 60 out of a bar, so that'd be something that'd be lovely just to let run. I have to do a couple changes to make that happen, but anyways, besides the point, let's get to that. Let's get to running machines and we'll talk over that instead of just yelling at the camera. Here we're going to swap out drills so I can use the larger one for the bodies. I make all these bushings for all the drills I use. You can buy them directly from Hardinge, but I always need them immediately, so when you have a lathe, it's easy to make round things. I want to double check that alignment because the body drilling is super critical that it's perfect. So the way I do that is I bring the tools really close to one another and then I slide, put a gauge pin in the spindle and then slide the bushing back and forth between both of them. So it's riding over the gauge pin and then into the holder. And once they slide smoothly together, I know my alignment is dead on. That little black holder on the right can actually fine adjust. You can loosen a few screws and fine adjust at 10 thou if you need to tweak it. And I thought it was catching a little bit on the back of the bushing. So I'm just taking a 5 thou skim cut off it just to make sure that it wasn't catching on the collet, or on the bushing, I should say. And then when we put everything back together, we should have some really, really, really nice concentric alignment. And then it repeats well, because once that black piece is aligned, I can just swap in any drill because I try to turn them all like in place, or like hold the drill and turn the bushing so everything is perfectly uniform. And then it's easier to swap out. So I need to do that for all my drills. And then we start the process. First, I'll use the Jacob's chuck, which is really not precise, but it's just going to bore a hole to get a boring bar in there. So I don't really care if this hole wanders or walks, because I'm going to open it up with the boring bar to get a really nice guide hole for the nice carbide drill, which will drill out the body. Here we come in with the boring bar, and I go in as deep as I can. And basically, I'm going to turn this or open that hole up to 2.505, so like 5/10 over the size of the drill, just enough so that when the carbide drill goes in there, it's a smooth fit, but not a wobbly fit. Just checking it with a little end of an end mill shank. And here I'm just checking the fit up to make sure it's going to be a nice sliding fit for the drill to go in. Like I said, I don't want it to catch it all. I just want it to act as a guide hole. And then we drill the pen out from both sides. And what I'm trying to do is minimize any kind of misalignment because the holes are going to meet in the center. So I sight down it after, and there's basically zero misalignment. I mean, it's taken me a lot of work to get to this point, but I'm still going to ream it after the fact. But the straighter the hole is off the jump, the way easier reaming is going to be. All right, this has taken me like 1,000 years, but I think I finally figured out why this turret, out of every few thousand tool changes, it occasionally will skip a pocket, which is obviously very detrimental when it's doing thousands and thousands of tool cycles while it's in production. I don't have the confidence to completely turn my back away because there's that 0.1% chance it'll fail. So this is how it currently tool changes. See, it's actually, that one is getting a little wonky. I got it at a good time. There, So that's basically how it currently tool changes. You can see those first couple cycles were a little kind of weird, but I'll show you how it now tool changes, which I think fixed the issue. And this is how it now tool changes. You'll be able to hear the difference. See that little click at the end? That. Basically, I'm just running the stopping pawl a little bit longer, and I think that's going to solve my issue of it missing, one out of every 1,000 odd changes. So if I can get it to run in its yeah, I think it's going to work. I'm going to run it a bunch to see if I can get it to fail, but so far it's very happy now. So I think I finally figured it out. It only took me 2 years. Here's a perfect example of why I want to get that new computer stand built, or the monitor stand that swings out of the way, because this wooden monstrosity is annoying to get around, especially when I have to get to the electronics cabinet to do any kind of work. Speaking of which, this is what the cabinet looks like. A couple power supplies for both servos, and on the left is all the control. So that's a Raspberry Pi 4 sitting on top of a rather specialty Mesa card. That's a 7C80, which is built for the Pi 4. Has a bunch of hardware stuff on board for pulse train generation and stuff, so it takes a lot of load off the software, doing more of it in hardware, which is why you can get away with the Raspberry Pi 4. Bunch of relays, only a few of which I'm using, but it's always nice to have a ton. Couple inverters on the other side. So the black one runs the spindle motor. The little gray one just runs a little oiler that just pumps coolant. And on the far side is a little clock motor that just runs a oiler pump, and that just pumps oil to the ways and ball screws. And I just left it be because it seems to work. Z-axis has a NEMA 34 ClearPath servo motor. So does the X-axis. This one just kind of sticks out the back because it was kind of, I could direct mount it, which is ideal. The X-axis is belt mounted, and it just fit in the stock location under the carriage, which I was very thankful for because that would have been a really annoying way to mount it because the other side would crash into the actual housing. So yeah, I was pleased I could get it in there. But anyways, that's it for this week, or that's it for today, I should say. No, this week. Yeah, it's Friday. So I'll see you guys next time. Take care. Bye-bye.